Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is reducing risks and estimation buffers in competitive fixed bids. Our guest speaker today is Mr. Janki Raman Jayachandran, Director Technology at TechCello. Janki is an ardent cloud enthusiast and a prolific speaker at NASSCOM and Cloud Connect event. He has 15 plus years of software development experience and was instrumental in defining the Cello architecture. Mr. Janki enables enterprises and ISVs to define their cloud strategy. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Janaki Raman.
Thank you. Once again, thanks everyone for taking the time to be part of this webinar today. So today we are going to be discussing on, as project managers, what are all the various measures one can take towards reducing the risks in the project, and as well as trying to minimize the estimation buffers, which we usually kind of bundle with the project estimation. And the whole idea is to enable these two factors in order to be able to be competitive in the fixed bids and other projects that you are delivering. So that's the broad agenda today. So we will get started right away. Let's start with some basic stats on the project challenges across the world. So project management as is challenging, and particularly when it comes to the estimation and risk management and the overall management aspects. There are several figures that can give us insight on the challenges that people are encountering across the world. So there are things like the project rework ratio. If you take, for example, there is a rework ratio of at least 25 to 40% of rework that is coming in, right? And 50% of products are getting rolled back from production. That's stated by Gartner. Now, some of these things actually boil down to the point of how well the project is thought out. So when you say it's rolled back out of production, it's because it's not able to meet what it is supposed to do at a real time. That's the reason it's been rolled back, right? So not spending too much time into this, but the point here is there are so many challenges around, and it's not just a straightforward thing. And there are so many other factors that are involved in the project management. We'll share a couple more insights into it before we get into the crux of today's session. So this slide kind of throws a nice picture given by Gartner, which gives an idea on the percentage of issues or the causes for project failure. So if you notice, the bottom stack, which represents the functionality issues, more or less remain the same regardless of the size of your project. So whether you do a small project or a large project, you still are talking about 22 to 24% of issues coming up. But what changes is the factors like the delayness of the project and the cost variance, budget variance that is coming to picture, which are causing the projects to fail or be abandoned or being kind of thrown out, right? So there are more than 50% of the cases fall under this category. Similarly, if you look at the stack of projects being delivered on budget, you could see how many projects are being delivered. Right? So almost 48% of projects are delivered, which is almost double the cost of the estimate, right? Double the cost of the budget. So 76% to 100% of budget variance happens in 48% of the projects. Now, this slide could look very familiar to project managers particularly, because these are the standard reasons or broad reasons why projects fail, right? Lack of requirements, clarity of requirements, scope of requirements keep changing, and then you have the resource related issues, and then the planning wise, the estimation, insufficient accommodation of buffers, right? Now, the point is, particularly for project managers, they don't have the luxury to state any of these reasons, right? They are there to be able to proactively manage these issues, being able to identify these things, sense these problems ahead of time, plan for it, and then make the project successful, right? Now, how do they do it? So the best way to be proactive is to have a strong risk management policy, right? Now, this is an interesting figure given by KPMG, which states the risk management approach of project managers, right, throughout the life cycle of a project. So, I mean, this figure may not necessarily not be accurate. It changes from case to case and companies to company. But broadly speaking, we see that there are like the risk management itself is one of the areas that is not too very strongly done in many projects. That's a reflection of this slide. So many cases, almost 85% of the risks are kind of left open, and they are kind of handled in multiple ways. Now, broadly classifying these risks, we can classify them into 4 different buckets, right? So one related to the vision, the system itself, what we've been trying to build, then the project-related aspects, the team, finally the resources. Now, the business risk, schedule risk, risk associated with the resources, as well as the team competency, team-related work risk. Now, those are, if you look at, pretty much homegrown for the project managers, right? And the areas of these risks are pretty much common across all the projects, and the level of best practices that can be shared is very high. Even if you go to, say, project management professional kind of a course, it talks a lot about the best practices applied on these 3 areas, right? But the 4th area, which is the technical and quality risk, is the most gray area among these 4, particularly from a project management standpoint, because this is kind of a black box for a lot of people, and it's not straight away to identify and do a great risk management in this area. And so many other external factors have to be contributing here. And the other important factor is the other 3 risk areas are pretty much self-impacting, or it may impact just 1 or 2 other areas. But a problem here with the technical and quality risk can affect the overall business. The project can get jeopardized. It could affect the team's competency, because the team should be competent enough to resolve these technical challenges. And finally, the schedule may also go for a toss if the technical challenges are going to be encountered in the project. So this is going to be the most crucial area, and people will have to focus more. Now, what do these risks constitute of? When we talk about technical and quality risks, one is typically underestimating the technical complexity of the system, right? So there is a difference between a requirement which states, okay, I want a booking form, a booking page. A requirement like this versus, now I want a flight booking form which is going to be operating 24/7, which is going to be accessed by thousands and thousands of users concurrently, and I want a great performance, and the backup of the system should be clear, right? You see, there are so many things that are getting added on compared to what was initial version of it. I want a booking form, right? So many times people just go with, okay, it's just a booking form, let me go ahead and probably put few hours for it, right? So underestimating the technical complexity is one factor. And then how do you manage system complexity itself? How do you manage the various requirements, the various configuration that needs to come? Because in the process, you don't want to end up with a code that is too clumsy, that is too difficult to manage down the line, because that's going to give you another headache from a manageability point of view. And then focusing on the extensibility, testability aspects, the architecture itself should be stable, right? And the system not being able to scale up, meeting real-time conditions, and performance issues that may pop up within the product or the application, right? So if you notice all these keywords that we talk about, they all boil down to one important aspect, which is the non-functional requirements of a project. Because all these things, if you look at, are pretty much common and can be applied to any kind of a project, any kind of an application, right? And same is the case with non-functional requirements, right? So what do you mean by non-functional requirements? Let's take a very simple example. Let's take 2 systems, right? One, a HR management system, right? A simple web-based HR system. The other one is a simple web-based banking system. Now, we'll kind of slice down these functionality or the requirements of these different systems into various categories. So let's take the domain requirements. The domain requirements are pretty much unique to that particular product, right? So HR is going to be focusing on employee addition, management of employees, and so on. Banking talks about customer management, payment processing, right? Very unique. Now, if you talk about the next set of requirements, which is the adjoining requirements, we have this user authentication, role-based access control, right? User-friendly look and feel. Now these are not the actual functionality itself, right? So, but these functionalities are required in order to be able to operate on the domain requirements, right? Similarly, the runtime quality requirements, like supporting X concurrent users, right? You may want to support a HR system, probably will require, say, a less number of concurrency, whereas compared to a banking system where the concurrency is going to be pretty high, right? So it could vary from system to system, but the fact remains the same, which is the concurrency aspect still has to be taken care of. It's the volume and the level to which it has to be supported varies. Similarly, from a software management perspective, the modifiability, how quickly can I change my software to make it more powerful down the line, right? Can it work in a plug and play model? Can I have single code base, but I want to be able to serve multiple customers? So all those aspects come under this category. So what is the typical effort spent on fulfilling the requirements? Whatever we saw, the 4 areas, 40% typically is spent on domain, whereas the remaining 60% is spent on the supporting area. This need not be true for all the projects. We have just taken some of the projects that we have experienced in the past and we have got data of, because many times, particularly when you deal with product-related functionalities, right? The product itself may have a certain feature, but then you need the supporting features to be much more flexible to be able to operate it. Similarly, the implementation-wise, if you look at to implement the non-domain requirements, you'll have to spend a lot of time on the architecture and design part itself. So here, as you can see, 80% of the time will have to be spent on the architecture and solution design, whereas the coding itself is very minimal, right? Now, why do I need to worry about the non-domain requirements, and what happens if I don't take care of? So this is again falling back into some of the project risks, right? Some of the reasons why projects even fail. So things like data loss. So you didn't plan for a proper backup, you didn't plan for a proper availability. Let's say you are doing a mission critical product, or say a healthcare product, and the healthcare product is required to be available 24/7 because healthcare institutions across the world may access the product, right? So you don't want the application to go down all of a sudden without any backup, or you don't want the system to work incorrectly, because that's going to lead to a lot more complex issues, right? So some of the key things related are the business loss itself, which is where you lose the project, you lose the customer, and then your ability to be able to respond back to customers changing requirements, how quickly are you able to address it, and how is the maintenance of this thing going to be. So one thing you can quickly write down code, but then how that code is structured, is it properly structured, is it well maintainable down the line, or am I going to spend double the effort in just maintaining it? So these are some of the key risks if you don't take care of the non-domain requirements. And looking at the overlapping part of it, the overlapping increases drastically as you look at the remaining 3 portions, the adjoining requirements, the runtime, and the maintenance requirements. And you notice that as much as 80% of duplication or repetition is there from one product to another product. Like I said, concurrency still remains the same. It's the value of how much concurrency you want to support varies from product to product. So getting into the non-functional requirements. So non-domain requirement, non-functional requirement, they are interchangeable. Non-functional requirements, there is a big list of requirements, but not all the requirements are, all the list of non-functional requirements need not be supported by every single application or product. This is where the project managers and the business analyst role becomes important, to sit and identify which of these NFRs are important for my project, for this particular customer, for this particular business scenario, right? For example, scalability is an NFR which talks about your ability of your product or system to be able to handle growing amounts of or volumes of data. So today I'm able to handle, say, 100,000 transactions per hour. So tomorrow, can I handle 10x times of it? If I have to handle 10x of times of it, then how much of change should I undergo? Is it a matter of adding another mission, or is it a matter of doing an architecture design rework? So that talks about scalability. So, and for certain products, it becomes very important. For example, we are doing the SaaS-related products, right? Multi-tenant SaaS kind of products. You have to plan for scalability. You don't have a choice, because your expectation is that you're going to get more and more customers down the line. So it's no more a choice, but you have to take into consideration. But if it's probably an enterprise application, maybe you know that it's not going to drastically change from 1x to 10x. So you may not give a very high importance to this NFR. But the crux is somebody has to apply their thought process to decide which of these non-functional requirements are critical for them, which are primary and which are secondary. Some of the things are really have to be thought about for all the applications. One is availability, how far the system should be available, right? Is it 24/7 or are we talking about 12/5? Only on weekdays it has to be there and it's okay if there's a downtime, or is it not at all okay? Do you want 100% availability, or are we talking about the 5 nines, 99.999 availability? Because it makes a lot of difference when it comes to your architecture itself. Right? Integration, how much of integration do you foresee? Do you expect to integrate with a wide range of variety of systems, or are you talking about just one system? Similarly, the second list also has various things. The deployment model, very important. How is this product going to be deployed? Is it going to be deployed on a on-premise? Is it going to be working on a hosted model? Is it going to be working on a multi-tenant model or an on-premise? Now, how do I support all these different models? Some customers, as a business strategy, they decide to go with a hybrid model, which means they want the product to be able to work in SaaS model, multi-tenant model, hosted model, as well as an on-premise. If this is the case, how do I keep it generic? Right? So some thought process has to go there. Some things like usability and how much of testability is there in the product. How quickly can I extend my product, modifiability and extensibility. So today I design my product, but tomorrow I know things may change. So if customers are coming with a change, how can I do the change? Or if there is an incremental thing that is happening, I already have a form done and I want to be able to add few more information to it. How quickly can I do this? So that's the extensibility part of it. So if you look at all these non-functional requirements, you will understand that it has a very good overlap with the functionality. So whatever focus you give for the product functionality, application functionality, similar focus have to be given to the non-functional requirements. And once you do that, you will definitely save a lot of time, a lot of rework. Functionality development becomes much more easier because most of the things are taken care by the NFR. It's just the logic of your functionality has to be focused on. Now, while handling this NFR, some of the common myths or common mistakes, common pitfalls. One, like I don't have an architect, so let me deal with the most senior most person in the team, right? So that doesn't work that way. As you saw, the NFRs deal with a different kind of approach. It's not the regular addition of a form or a regular crude operation that we are talking about. It deals with the design of how your system should work, the blueprint of the system itself. The other common mistake is the NFRs. How do you define the NFRs? Now, in some cases, customers are also not very clear. They will say, I want a high performance system. I want a rock solid system. These are very vague terms. Now, how do I measure if a system is rock solid or not? That's very subjective in nature. So one thing you need to do, whatever list we saw here, you need to be able to put a number to this list, right? So when I talk about scalability, what am I talking about? It should be scalable. System should be scalable to be able to meet 5,000 concurrent users. Now that's a more a tangible version of NFR, rather than saying I want a very high scalable system, right? So that's one common pitfall. And the other problem is the estimation for this NFR. So again, what happens is this NFR gets lost across the product. So it gets merged with the functionality and it goes to the developers for estimation. So like in the earlier example I said, we're talking about a booking form. Okay, it's a simple booking form, let me go and put some hearts. This is what a developer is going to think, right? Now, if the same is done by an architect, he knows that it's not just a booking form, it's about developing a highly scalable and expandable system which can take up any kind of load. Right? That's a kind of an estimation that has to be done. Otherwise, you're going to end up with an incorrect estimation, leading to again problems later on. And NFRs being handled in the end is another typical mistake people do, because we feel that towards the end we can take care. Let's build a system. Let's do a performance testing. Let's tweak it later on. Now it's not just like that easy to tweak it. It's okay if you're tweaking it for a few seconds, but you cannot tweak it across for minutes, right? So end of the day, if it's taking 5 minutes to finish a task, it's totally not acceptable, right? Your end user is not going to accept it. And the other common myth is the NFRs can be handled if you just put some buffers. So this is where the fixed bit quotation itself goes up in many cases, because the functionality part, the project manager and the team are very confident. They go ahead and put the exact numbers. But when it comes to this technology risks and the non-functional requirements, they don't have that level of confidence, so they end up quoting some kind of buffers into the estimate, hoping that that buffer should help them to take care of it. So there is no tangible approach or a framework in which they will be able to measure this NFR. We will see how to measure this down the line. We have a small calculator which we can show you to estimate this effort. Right? So these are some of the typical myths involved. And how does a framework help here, right? Software framework typically is any reusable software platform which can be used to develop any kind of application, any kind of product. And we saw in the earlier slides that we saw an adjoining requirement with overlap of 60%, right? And then the other two, runtime and maintenance requirements, overlapping up to 80% of it. So framework typically concentrates on this commonality between these various products, so that people need not put their minds reinventing the same wheel again and again. So that's essentially a framework is all about, and it focuses mainly on the non-functional requirements, right? So which in turn will increase the productivity, will be like booster when it comes to developers being able to develop functionality on top of it. And it also kind of demarcates the job, right? It clearly demarcates the developers from focusing on the functionality versus architects focusing on the overall design of the project. Right? So it gives a nice demarcation as well. And very simply, developers can now just focus on just developing and debugging instead of trying to do the underlying plumbing related work, which they are not well suited to do. Now, why do I need a framework, and what if I don't have one? There is a set of challenges the team undergoes when they don't have a framework, which you have seen in several projects, in several customer cases. One is developers, they need some place to get started. What happens particularly in agile kind of projects, there's one other common mistake people do, that okay, I'm doing an agile project, so I'm going to start by sprint. So I'm going to take the first sprint, I'm going to take some functionality, start building it, and then I'm going to keep doing it in pieces, in chunks. That's what agile is about. But they fail to understand that agile also indicates that the sprint 0, which is the first sprint, should focus on the architecture of the project. Right? You need something, some base, which has to be given for the team to be able to start working on top of it. Right? So developers need something in the first hand to be able to get started. And they also have difficulty when it comes to the step-by-step things as to what is required to build a successful application, right? So where do I start, what kind of technology should I use, and how do I glue all these different pieces together? So they are often kind of left to make decisions on their own. Sometimes it goes wrong. And more importantly, developers are under time pressure, so every project has its own constraints. So they end up taking up shortcuts. Right? They don't tackle it at a design level, but they rather try to tackle it at a code level. So if it's a security thing, they don't think through across the system. Instead, they do a simple if condition check for that page, hoping that that page now works well for security. But the point is the entire system should be secure, right? And it also opens up a scenario where every developer or many of the developers try to solve the same technical problem, right? So they try to do security check in their own style. Every developer comes out with their own style. And overall, it ends up with an application which is extremely hard to maintain and extend as well. So what is the framework and how does it look like? Well, this is an example of a SaaS framework. We have taken an example of a SaaS framework here. So as you could see, you have a plumbing stack here which deals with all the common plumbing related things like how do you handle exception, right? How do you do logging? What is the mechanism for auditing? All these things, if you look, are common, right? Every developer is going to handle this piece of it. Now, instead of having them do it, you tell them that, okay, these are the various libraries available. So if you want to do an exception handling, you use this. there is also enterprise library which could be used here. So we'll keep that apart for now, for the side for now. But the point is, when it comes to all these basic operations, utilities, make it available as a stack to them. And then there is a set of engineering related stack which is very particularly done for SaaS related projects, like multi-tenant or which could also be used for enterprise related applications. So when you work with applications with high configurability, this framework has a configurable UI, for example, which takes care of UI level customizations. And then there is a custom workflow builder. So in case if you are doing a workflow, you could design workflows according to the customer using this module, right? And then you have the user management, the ability to track various events within the product, the ability to schedule tasks within the product, notification, for example, being able to send out notifications to a lot of people through the form of emails or FTPs, right? So all these again are common things, and each module does a particular job. These modules can be used by the actual product, and the product itself sits in the top. If you see in the top, you see the product specific functionality. That functionality can utilize these modules, which means they don't have to think through how to do a roles and rights management. They don't have to think about how do I handle with configuration of my UI, right? It's all taken care already, so the product functionality can move faster. And in this particular framework, all these engineering stack works under the context of tenant. This is a SaaS multi-tenant framework, so it applies the multi-tenancy at all levels. So you know exactly which customer has done what customization, right? So which tenant has done what settings. That is always kind of tracked, and then only that particular information is retrieved or acted upon. There is also a SaaS operational related component which provides a set of modules that deal with the management of the SaaS product itself, right? Like we saw, this is no way a direct functionality of an end user, right? A tenant provisioning is basically a feature that will allow you to add a new customer into your system. Now this is purely for your own operational efficiency sake, right? The end user is not going to be using this feature, but then the operational guys of the ISV or the organization that is having this product is going to use this. Similarly, licensing, how do I package my product differently? How do I consume, or how do I meter the consumption of my product so that I can bill my customers according to the usage? So again, these are things which are done at the operational level. Now, how does a framework help? And one, as we saw, it gives the focus on the functionality, the product functionality, instead of the underlying plumbing layer. And we just saw that the duplication of effort now is no more a reason, because you have done all the common things and made it available to the team. So it's a matter of educating the team to tell them what to use in what scenario. So the rework percentage comes down drastically. And then the estimation accuracy goes up pretty high, because now developers are much more comfortable in estimating the functional requirements. And the non-functional requirement itself is taken care by the framework. So they know it very clearly, and they give you a more optimal estimation, which again will be very helpful when it comes to fix the project. And reusability of the code, which is already pre-built and pre-tested. So if you take an existing framework, then you already have it well tested and available. So you don't have to really spend time on that again. So the time can be focused only on the functionality, and then the whole reliability factor also increases. And the more important thing the framework also kind of establishes is the practices, best practices, right? So nothing like doing things correct in the first time, right? That's the best way to finish a project quickly. Now this framework also establishes a set of engineering standard, a set of programming practice, so everybody knows how to implement a certain security norm. So they do it in a uniform way, in correct way, right? So things becomes much more easier to handle. And also the NFR being focusedly addressed within the framework provides you an avenue where if things change tomorrow, for example, the security model has to be changed, then you have to just change it within the security model of the framework instead of going and changing it across your products. So handling changes becomes much more easier and very cost effective. And overall, this framework reduces to a great extent the technology risks, the technical risks which we saw in the earlier slide related to extendability, testability, I want an unstable architecture, performance related issues, scalability issues. So those are the things, risks that are now addressed by the framework itself. The other advantage from a services organization perspective is you do several projects, right? And several projects, like I said, the domain or the functionality of those projects could vary, but the non-functional requirements will still remain the same. So when you take a framework approach, you give a standardization of the technology itself, right? So you decrease cost to a great extent because the same thing can be used again for your next project. So then the overall estimation of the next project, if you look at, drastically comes down. It gives you a very good competitive edge. And you also end up having developers who are comfortable with the framework. They would have used it, so they know exactly how it works. So the next project goes very smooth because they are not forcing any new surprises over there. They know exactly what to do. You get a tested and proven framework and you do this repeatedly. And at the end of the day, again, reduces the technical risk. Now, having understood on the framework side, what does it take to build a framework? Well, it does take a bit of investment, but it's worth investing because you are going to be ensuring the success of the project at the end of the day. Looking at the skill set level, this chart kind of gives you a high level information on what are the various skill sets required across the phase of building a framework. Now, framework development itself has to go through almost an SDLC. So you have to collect your NFRs, you have to design for it, do an architecture, you have to code for it, and then you have to do a testing of the framework. Now this has to be done like independently almost, so that you are sure about the framework and it's working. And you see the kind of skills that are required. So predominantly if you look at the architecture and design phase is where your technology people will be required, tech leads and tech archs, to be able to come out with a solution. And this again shows the kind of effort that is required from the senior people. So if you look at 25, 16, 19, almost 60% of effort has to come from the tech arc, tech lead, and the senior engineers in the team. So that's the kind of effort that should come from that senior people team in order to be able to come out with a successful framework. And then comes the question of do I need to necessarily build my own framework? Having seen the amount of effort and the senior people availability to build something like this, is it required that I need to build it by my own? You can take that approach. Some customers take a custom development approach where they want to have full control and they want to develop it from scratch. Of course, it takes a lot of time, but they have their own control of every single decision. As an alternate, there are also several frameworks that are available in the market that can address various types of NFR requirements. Right? Now, so we'll particularly pick up the Cello framework. Cello is one such framework. It's a multi-tenant application development framework. In fact, the framework slide we saw earlier is actually from the Cello product itself. So it comes with a set of engineering and operational modules like we saw in that slide. And Cello particularly can save anywhere between 30% to 50% of the time and cost which will have to be spent in building a typical project, a typical application or product. Right? So it's a straightforward calculation. Right? You can think of 30 to 50% of cost saving, what it can do for a competitive bid. Right? So you can quote at almost half the price of what your competitors are going to quote. So that's going to put you across in a different level altogether. And this framework approach also will be well received by the end customers because they see a value add coming through this. It's not just you are cutting down the cost for the sake of winning a project, but also you are bringing a value add to the table by bringing a robust architecture and framework. And Cello particularly uses .NET technology, and therefore there are no additional learning curve for developers. And it yields a very high return of investment, an ROI which can go as much as 150K USD on your budget. Right? So that's the framework part of it. Now we will also quickly take. I will also show you an ROI calculator. Right? So it's a calculator. It's a calculator that that will allow you to be able to estimate the non-functional requirements, which will help you to size the kind of effort that is required when you are considering for a fixed bid, right? So just give me a second here. I'm going to open the Excel template. So in the meantime, if you have any questions, feel free to keep posting the questions. We should be able to answer as much as we can given time. So we have some questions already lined up. So we'll take a couple of questions while we are in the process of opening up the template. So there's one question from Vishal Verma. Usually the effort estimation is quite yearly in the project and specifically for fixed bid. You have a competitor as well. The level of details like architecture and framework is not decided by them. So you have to normally make many assumptions on how this should be handled. That's a very very valid question, and pretty much the scenario across everywhere. Now, the best approach you can take is there is always going to be an idea of the size of the project that you are dealing with, right, and the nature of the product you are dealing with. What happens is when you do the first cut of your estimation, many times people tend to miss out, or like we saw, underestimate the technical complexity because they don't have a checklist. They don't have an idea of what are all the various things that may impact the system. Now, the ideal approach in scenarios like this is to, if you have an NFR, what you should do is you, based on your level of understanding, you take the 5 or 6 non-functional requirements, do your own assumption. For example, when you take scalability, you can say, okay, based on understanding, I feel that this system should be scalable up to 3,000 concurrent users. Similarly, put for availability. I feel the availability should be okay if it is like 99.99%. So like this, if you list down for each of the non-functional requirements, and based on that assumption, you size up your estimate, and then go back to your customer and submit it. It does multiple things. One, it gives a proactive approach, right? So your customers will see it as a value add. They see that you are thought through on different angles, which they themselves might not have done in some places. And then, even though your numbers are going to be high, say for example, they understand that okay, it's because of these assumptions they are thinking you are come up with this number, and then they come back and say, okay, I don't think I need this level of scalability, you can cut it down. So they start giving their own recommendations on these things. So it's a nice guided approach to have your customers or pull the information from your customers, and then also safely keep revising your estimate. But if you go in the first place ignoring all these things, then you are already in a trap because you're given a less number, and then going and increasing the number is totally unrealistic. So customers are not going to accept it. So we have the ROI calculator up now. So this is a calculator. We'll also share the link for downloading this calculator so that you can try it yourself. We have put together this calculator to achieve 2 things. One, as project managers, as developers, you can use this calculator to find out what kind of an effort has to be put in order to be able to build some of the common non-functional requirements. So we saw a set of NFRs, right? So this tool provides you a number, and a very tangible number to each of the NFR items, right? So that you know exactly what it takes, and then you can go ahead and consider it in your project estimation, right? That's one part of the thing. The other part of it is also a comparison or on the ROI that you may get by adopting a framework, in this case Cello framework. So you will also see a comparison chart and ROI chart of it. It has instructions you can also go through. So I'll just quickly run through some of the key usage of this particular ROI calculator. There is an assumption sheet which talks about a few things like how do you want the report to be seen. So if it's like any of the unit you can pick up, I leave it at person hours. And then what do you think is the average resource cost per month? Right, so let me probably put 1000 USD is the average resource cost I'm going to spend, right, per month. Now, how many developers are you going to use in building this application or project, and how many production servers do you foresee to use? The last two are more to calculate from an Cello perspective, right? What does it take? Now, this sheet is the key sheet which has the complete set of items that deal with the non-functional requirements. So there are close to almost, I guess, close to 300, almost 295 line items are there. It is a very exhaustive list, and what it does is we have organized it into several line items. For example, the first level is a stat level, right? So you have the non-functional requirements, and then you have components, operational related things, engineering related aspects. The second level talks about, expands further. Now, under NFR, what are we talking about? So we're talking about customization, security, integration, and at the component level, we're talking about the business rules, workflow. These are all generic things. So you could use the business rule for any product, any application. Similarly, workflow can be used anywhere. This is the ad hoc query builder and report builder, right? So it gives a second level of module. And then a third level, which goes at the feature level. So within customization, what kind of features are we talking about? So here it starts with a simple UI change like themes and logo change to even going to the extent and changing the fields of a particular entity. So you have an employee form in your application, and if a customer comes and says, I want to add, I should be able to have the ability to add 2 more fields to it, because when I go for implementation, my customers may ask for different information. So I should be able to quickly add these 2 fields without much of a data engineering work. And how do I do it? So extension fields will give you the capability. So on the fly, you can go add dynamic fields to your entities and bring them into the UI, right? So the data view extended fields gives you the capability to even bring that newly added fields into existing screens of your product. All this done through the UI itself, administration UI, done within minutes. Right? So it saves a lot of time when it comes to the implementation cycles. So this is an example of what customization can do. Similarly, user security management related aspects, dealing with the user role privilege management. And one thing that typically happens is people would like to have a granular level of control, which means they don't want to just stop at just a permission level, but then they want to be able to handle it at a role level, at a permission level, at a entity level, at a user level, right? So they want very granular level of dimension, security matrix dimension, so that they can exactly specify what a user can do and cannot do within the system. Notification, like we saw, ability to send out emails, shoot out emails, FTP kind of things. Right? On the components front, you have the business rules. One great advantage of business rules is in many cases, many products, particularly with the products where it changes from one customer to another customer, things change, right? So what we typically do is within the code, we tend to do a check. So developers tend to do a check, okay, if this is the customer type, then do this business logic, else you do this business logic. Now that's a pretty easier way of handling, doing it faster, but then that's not a scalable one. And that's not going to give you a maintainable code at the end of the day. A business rules module will help you to address these kind of variations, business logic variations from customer to customer or scenario to scenario, right? Take it out independently and handle it at the business rules engine level, so that your product will still be a generic product, The product will simply consume a business rule and execute based on the result. So what you have done is you have eliminated the variations from the code to a framework level. And the code now becomes much simpler to read, maintain, operate, and develop as well. Similarly, workflow, you will be able to define multiple workflows. Say if it's a HR system and you want to define a leave management workflow. So leave management workflow can change from customer to customer, right? Or from scenario to scenario. Now, how do I define it dynamically? How do I make it operating dynamically? So again, a workflow designer comes to the picture. Similarly, the ad hoc query report builder and operational related modules like tenant management, tenant hierarchy, right? So these are more specific to SaaS related projects or applications and products. And there are a good number of enterprise applications also today which almost need the same kind of tenant architecture, multi-tenancy architecture. Because what happens is multi-tenant in nature is not necessarily a SaaS, a particular one. It's a generic approach, a style of architecture which allows you to handle different group of users under different settings but using the same code base. So it could be one large enterprise. You may develop a project for one large enterprise, and the enterprise may have a US division, a UK division, and they will say, okay, this particular functionality has to work in this way for US and should work for UK like this. The same leave management, if you take, the leave procedure may differ from US to UK. So you end up building a single system which is going to be used by a single customer, but then two geographies need two different styles of working. Now this can be achieved by using a multi-tenant approach. So multi-tenancy not necessarily is only for SaaS, it could be used for the enterprise solutions as well. And today more and more enterprises are taking up this approach because that gives a lot more control and security as well as a flexibility for them to operate upon. So this is a broad list. I mean, you can go through this, you can download this and go through in detail. I'll just tell you how to operate on this list and what does it encompass. The X marks that you see are the selections. So you are allowed to do selections at any level. For example, you can unselect a module and that particular module will be deselected, or you could also do unselection at a feature level. Right? For example, you can unselect at a feature level, and there is also a fourth line item which we didn't see, which is the capability level. So you could even go to capability level and mention that I don't want this particular capability. So it's a very granular level of control that you will have to determine what is available for you. So the idea is, based on this list, you have to determine what is required for your product and then do the selections accordingly. Right? You will also see a quick view of what does it take to build that particular line item or that group of line items. For example, here we are talking about customization. It's going to take, for example, 1763 unit, and the unit comes from here, which is person hours. Right? You could also change it to person days, and maybe look at the report as well. So it reflects in days now. So it's 220. Right? Now, so once you have done all the selection here, you could go to this sheet, ground up sheet, which throws you a set of reports, right, which can give you an idea of what does it take. So here I have made some selection, right? I have deselected few items. Now it gives me all the breakup of what do I need to do it by myself, right? By my own. So at the outset, it says the total effort of almost 3,000% is required if you want all the 300 line items. But not necessarily all the 300 line items will be required for you. So you may have to pick and choose. And this is the overall cost of what it brings you as well. Now the following is a series of charts which will give you a nice breakage of this information so that you can analyze it in more greater depth. For example, this one gives you the effort distribution by the layers. So we saw NFR, we saw components, operations, right? So it gives you a breakup by these 4 layers. Similarly, the effort distribution, where does your effort get in? So 39% of effort has to be spent on building your NFR stack, 36% on your components, and so on. This is the same by phase, and then the skills involved by phase, we saw this earlier. Similarly, by skills, and effort breakup by phase, so which phase, how much are you going to keep spending. And then interestingly, a timeline to complete. So if you want to build everything by yourself, assuming you put a 2-people team, it's going to take you almost 75 person months, right? Whereas if you put a 16-people team, you may probably have to spend 9 calendar months to finish this, building this framework. So it gives an idea of what does it take to complete building it with a team size of 2, 4, 8, 12, and 16. Similarly, from a cost perspective, where does your cost go into? We saw 153K being spent, but where does it go into? And remember that this comes from the basis that you are spending $1,000 per resource per month. That's the basis in which this cost is being calculated. You can go ahead and change it according to your own thing, but ensure that it's in USD. So do the conversion from INR to USD if you are dealing with INR. This is a further breakdown by module. So there are several modules, right? Channel management, query builder, customization, event hierarchy. So by module, you'll be able to see the percentage split up and the effort split up. Similarly, the cost split up. So all this from a ground up development perspective. There is also another sheet followed by it, which can give you an idea of what does it happen when you do it using a framework like Cello, for example. So the ROI here, if you look at, so you can straight away save the effort, which is the 3,000 odd percentage can be straight away saved, and then you can save, say, approximately around 30 calendar months. Ground up cost, you would have spent 153K building this, whereas Cello would have costed you 25K because you are buying the 5 developer license and says 2 server license. So Cello comes with based on developer and server license cost. So it's going to take up 25K. So straight away you make a saving of 128K on your project, which can again be directly reflected on your bid, right? You can become so much competitive with the kind of savings that you can get there. And not just that initial savings, but also down the line. If you have built something yourself, you're going to keep maintaining it year on year, and which is going to add up to another 204K, which you'll be spending on the next 5 years, right? So this chart below gives you a year-on-year comparison. So first year you would have spent 153K building it yourself, whereas 25K if you are choosing Cello. The second year onwards you will spend 30K, 38K, 42K, 45K, and so on year on year in maintaining the thing what you built. But whereas here it goes by AMC, so you spend a very fixed amount, and then the whole cost difference gives you a lot more competitive edge. This slide again talks about from a cumulative perspective, what is the return on investment. So the return on investment can be as much as 382K in this scenario. This is all with the assumption that you have chosen all the line items. Like I said, if you pick up the line items that are relevant for you, you will see a much more a figure that is relevant to you and which is more realistic for your case. So we have this sheet available. We will be able to share this with you. The URL of it is also available right here in the slide. We will share the slides as well. So that brings us to the end of this today's webinar, and I hope you found it useful. So the whole idea is to ensure that you leverage some of these framework-related aspects, reduce the technology risks, because so much of technology solutions are already built in the framework, so don't try repeating it. And 2, being able to take this advantage, cost advantage, and bring it back to your customers and reflect it through your bidding, which will also help you win more customers. So with that, we will open up for maybe a few questions. So feel free to post your own questions in the question panel window. Okay, so we have a question from Bhaskar Kumar. The question is, what is the difference between experience-based estimation and functional point estimation with respect to FR and NFR? I mean, this is more of a philosophical question. Like experience-based estimation, nothing can compete with an experience-based estimation. Because if you have done a project, if you have done end-to-end SaaS development project, you know, for example, what it takes to build it. Now, not many of them have that experience, and that is where the framework part itself comes as a help. So we saw that so many line items gives you an idea of what all it constitutes of. Now you get an idea and then you take it as a guideline, as a checklist, then you go ahead and do it with your own estimation model. Whether you do it with any estimation technology, that's up to you. But then you'll be able to use this as a guideline in your estimation process. There is a question from Ashok Jain, which states, does new framework also manages dynamic scoping? I'm assuming dynamic scoping refers to your ability to include new customizations, new features dynamically into the product. Then yes, it is feasible, it is possible. Like I said, you can dynamically bring in a set of security features, you can dynamically bring in customization features, you can dynamically do data filter scoping. Usually data filter is done at a row level. You could also do at a hierarchy level, at a relationship level. For example, I should be able to see only records of my subordinates. Now this is very subjective, right? Which means it can change from person to person depending on the level. So framework brings in all these things called data scope, dynamic data scope. For example, is one such feature of the framework which can address this. How many test iterations considered in this effort estimation? Abhishek Kulreshta. We have taken the standard development life cycle, which constitutes of 2 test iterations, 2 complete end-to-end testing cycles, which is the standard we typically follow, right? So the breakage, everything, like I said, requirements, design, architecture, coding, testing. So testing includes 2 cycles. Chandrasekhar Shivanand has a question around, do you have any advice on apportioning the framework cost across or each customer? This apportioning cost, the framework cost itself is something that is actually a good thing to do, because when you develop it for your own and then you try to use it repeatedly for several customers, you don't want to be able to apply the entire cost to a single customer. So when you get a savings, for example, you're able to save 100K out of the framework, you should be able to at least take 1/5 of it to the customer, right? And then that way you're able to recover some 20–25% of savings from each of the customers. That could be a kind of a benchmark for you. Okay, we have some more questions. There is a question from Riju C. How can we create our own framework? Yes, like we saw, there are the entire list of what a framework constitutes is there. We just showed you. It's also available. You can download it. So what does it take? It takes the amount of effort that we just saw. It takes the amount of senior technical people's availability, and then you should be able to do it yourself. So in this case, when all the items are selected, we saw it took almost 153 person-months of effort. So if you could afford an effort of that size, you would be able to build your own framework. So I think that's pretty much the questions we have for today. And once again, thanks everyone for taking up the time. And we will be sharing this presentation through TechCake, and you should be able to download. And you also have the contact details here. In case if you have any further questions, you can feel free to post it to the email.
Well, thanks for the insightful presentation, Mr. Janaki Raman. It was indeed a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of this session would be available on techgeek.com by evening. Thank you all. Have a great day.